Okay, in this video I have three masses, a 10 kilogram, a 6 kilogram, a 3 kilogram object. They're all in contact with one another. A 20 Newton force being applied. What we want to determine here is what's the acceleration of each block and what would be the force between the 3 and the 6, between the 10 and the 6. Now the thing to note when you have something like this, the force between each of these is not going to be 20. Between the 10 and the 6, and between the 6 and 3 will not be 20. Show you what to do on this one. The first thing I would do on this one would be draw a free body diagram of each object. Now, since 20 is the only net force in the system, you could say immediately, and we'll prove. I'm going to prove this is true. We could go back and say that F is equal to mass times acceleration, and we could say our net force is going to be 20, and set that equal to our mass, which will be 19. And times A, so acceleration should be equal to 20 over 19 in this case. And if we run that number real quick, 20 divided by 19 is going to give me 1.05. So again, we know the acceleration is 1.053 meters per second squared. And that's fine. I mean, we can work it that way. I'm going to just work this problem as without even doing this to prove that I can get this value. So what I did is I drew a free body diagram of the 10 kilogram object, and this is what it would look like. This is the free body diagram. This is the 6 kilogram right here. And this right here is a 3 kilogram object. So it's very important you can draw good free body diagrams of the objects because it makes things so much easier and all your answers will just pop right out. It's really easy. Okay, so if you notice here with the 10 kilogram, I show the 20 Newton coming to the right. Now the only other force that's coming back to the left is the force that the 6 kilogram object is going to have on the 10. So I labeled it as 6/10. Then when I come to this object here, the 6 kilogram object, the 20 is not touching the 6. The forces that's going to be present is going to be the force that the 3 is pushing onto the 6, and the force the 10 is pushing onto the 6. So I label those like that. And then when you get to the 3, the only force you're going to have is the force the 6 is onto the 3, and that's the only horizontal force you have. So at this point, we can just write our equations. We can say the summation of forces in the x must equal to mass times acceleration, and we will get minus force of 6/10 plus 20 is equal to the mass times acceleration. The mass of that is 10, so it'd be 10a. So there's my first equation right there. Let me make that a just a little bit better than that. There we go. And there's going to be my first equation here. I come to the second equation, or object here. We'll look at that. Summation of forces in the x is equal to mass times acceleration. We got F of the 3 kilogram object putting onto the 6. We'll make that negative. Going to the left, plus the force the 10 is pushing onto the 6. And we'll set that equal to 6a. Second equation. Come to the third equation. Third equation, we really don't have very many forces. Scroll down. I do the summation of forces into the x direction, set it equal to mass times acceleration. I will get the force of the 6 kilogram object onto the 3 kilogram object must equal to the mass 3 times a. And those are my three equations. At this point, you can solve these several ways. You can substitute back in if you choose to, or you can do elimination, or you can do matrices. It really makes no difference at all. I'm just going to set up in the matrices because I think it's easier in this case. So what I'm going to do is I'm set this up as F of the 6/10 will be in this column. I'll select the F of the 3/6 in this column. I'll do acceleration, and I'll do my values over here. Come down. I'll just put all the values back in. So take this equation right here. I will get a minus 1. I'll move the 10 over. That gives me a minus 10 here. We have no 3 6's in this equation. We move the 20 over, we get minus 20. And there's the first equation. We take this equation, we got a 10, 6, so I got a 1. I got a minus 1. We move the 6a over, that's minus 6. And I got 0. Scroll down. Third equation will be based upon this one. We got a 0. We got a 1. We got a minus 3. And we got 0. So now we have a 3x4 matrices. All I have to do now is go in and run those numbers. So I go to my calculator. I got most of these values already keyed in, so let's see what we can do here. I got a 1, 0. Let's see here. I thought I had these keyed in. I guess I don't. Let's do second matrices. Okay, 3. All right. So I'll put these in real quick on my calculator. We'll run the numbers, and we should be good to go. Matrices, I go to math. Okay, so now when I run the numbers, what I get is F6/10 is equal to 9.47 newtons. I get F of 3/6 is going to equal to 3.16 newtons, and I get my acceleration is equal to 1.0526 meters per second squared. Alright, so now let's just verify if that is correct. We'll take this one right here. Let's see if I can grab that one. We'll edit, copy it. We'll just do a spot check to make sure we're right on. Move this down here. Again, let's sum the forces and see if we get it right. Alright. So F610, in this case, I should get minus 9.47 plus 20 is equal to 10A, and we'll verify that is correct. So when I take 20 minus 9.47 divided by 10, I get 1.053, and that's exactly on. So that's our spot check. We've got exactly the same acceleration within rounding. So we know we got it right. So that is correct, and that's all you have to do with this problem. Again, don't feel like you have to do it with matrices. You can do it by just substituting back in and working your way back through the equations and get the answers. Alright, so that's how you work objects when you have several different masses with one force being applied.